Okay, I'm going to give you a bunch of equations, more like functions, and we're going to learn how to write the domain for each of those. So here's part A. So if I give you the function f of x is equal to, let's just do 3x plus 2. Okay. So what type of a function is that? Is it a line? Is it a parabola? Is it a circle? What is it?
A line.
It's a line, right? And what's the domain for any line that you could ever get? The domain is all real numbers. Unless that line is a vertical line, then of course it's not a function at that particular point, so we wouldn't even consider that one. But anytime you get a line, the domain is going to be all real numbers. Okay, let's do example B here. What if I give you f of x is equal to, what about 3x squared plus 2? What type of function is this? It's a parabola. That's a quadratic function. Okay, get that picture of the quadratic in your head, right? What would be the domain for that one?
All real numbers as well.
All real numbers as well, right? So for any x that you give me, I could point back to you where the y location should be. Like for example, if you give me x is 0, I'll tell you that y is 2, right? If you give me that x is 1, I would tell you that y is 5 in this particular case, right? So every x you can think of, I can tell you exactly where that y value is. That's why it's all real numbers. Okay, now it's going to change a little bit, okay? Let's go see. What if I give you this function? F of x is equal to the square root of x minus 3, all right? So let's actually take a look at this graph, okay? And the function I gave you was f of x is equal to the square root of an x minus 3. Okay, let's make this an f, okay? Okay, before I even graph this, we should have an idea of what it's going to look like. So you guys tell me, what is this graph going to look like?
Is it like to the right 3?
It's a square root function, but it's been moved to the...
It goes like up like that.
It's the weird curve, but where's it been moved?
It's going to start at 3. So
To
it's
the
from
right
3
3
to
in it.
infinity.
Very good. So the graph should look something like this. Is this what you guys are all describing to me?
Yes.
Yes, you're absolutely correct, okay? So if I take this picture, I'm going to take this picture and I'm going to copy it. I'm going to bring it over to our lesson here. Okay, how would I describe this how would I describe the domain?
Starting at 3 and continuing to infinity, but including 3?
Okay, yes, so one way would be 3 to positive infinity. That would be interval notation, right? How would I write it as an inequality? X must be greater than or equal to 3. Very good. So this is interval, inequality, and then the one that the book uses in this particular section that we're going to use right now is set notation. So we're going to say this is all real numbers x such that x is greater than or equal to 3. And that's the one that we want to be able to write down. And we want to be able to connect that with the picture that you see right there. So does it make sense, what I wrote down in the algebra terms and then the picture? Okay. What if I gave you this, though? What if I took the picture away? All right. What if I took the picture away? And it doesn't want to work right now. How would you do this without looking at the picture? That's my question I have for you.
You would use the 3 that's under the square root sign.
Okay, so if we take this picture away right now, and I just look at this, right? I have to always keep whatever is underneath the square root greater than or equal to what?
X.
No? 0, right? Can I take the square root of negative 5 in the real number system? No, I can't. So remember this. Whenever you have the square root of stuff, okay, and whatever you have the square root of stuff, in order to find the domain, whatever the stuff is, whatever it happens to be, it must be greater than or equal to 0. Make sense so far? So look what I had here. The stuff in this case was x minus 3. So if I set x minus 3 greater than or equal to 0, and I solve this little inequality, look what I would get. X would be greater than or equal to 3. And that's exactly what we said that should be for the domain. Does that make sense?
Wait, so
What if I gave you f of x is equal to the square root? What if I did 2x plus 1? Okay. How would I find the domain of that function?
X is greater than or equal to negative 1/2.
Good. All real numbers x such that x is greater than or equal to negative 1/2. half. Jack, how'd you do that so fast in your head? What did you do?
I just subtracted the 1 and divided it by 2.
Yeah, you just took whatever was underneath the radical, which was 2x plus 1, and set it greater than or equal to 0. So therefore, 2x has to be greater than or equal to negative 1. So therefore, x needs to be greater than or equal to negative 1 half. And that's what we came up with right there. So if I was going to graph that, we should see that x needs to be greater than negative 1 half. Does that make sense? All right, good. I got 2 more for you in this case, okay? Let's do this one. What if I give you f of x is equal to 5, actually no, 1 over x minus 3. Okay? 1 over x minus 3. So let's go ahead and take a look. I wonder what this graph looks like. Okay? F of x equals 1 over an x minus 3. Now, before I even graph this, we should have a really good idea of what this should look like. What's the parent graph for this one?
1 over x.
1 over x. What's that graph look like to you guys?
2. I don't.
It's the Hurley graph. It's the Hurley symbol. It looks like the Hurley Surf Company symbol, right? Okay. But what's that minus 3 going to do? Move it to the right how many units? 3 units. Good. So when I graph this, look what I get. There it is right there. You see that? Now, what are you noticing at the line at 3 right here? What are you noticing?
It's an asymptote.
It's an asymptote, right? So if I was going to graph the line x equals 3 and put this on here as well, so you'll notice that this graph, this function, it passes the vertical line test everywhere except where?
3, so all real numbers equals, or x equals all real numbers except 3? Or
Yes.
Excluding 3?
You're absolutely correct. See, let's bring this back over here. So here's the picture that we came up with, okay? And I want you to be able to connect the picture to the actual graph, okay? Let's say that I didn't have that graph. How would I go about solving this thing algebraically? What would I do? Well, this is a fraction, right? What can you never divide by?
0.
0. So therefore, we could set the denominator, x minus 3 is never allowed to be 0, right? And I would solve this equation for x. So if I added 3 to both sides, I would get x is not allowed to be the number 3. So the way that we would write the domain is this: all real numbers x such that x is not allowed to be the number 3. So I want us to be able to connect that to the picture, right? Because we're seeing at the point where x is equal to 3, there's definitely a vertical asymptote, which means it fails the vertical line test out there. So we say the domain is all real numbers except for the number 3. Ooh, how would we do this one? 1 over x squared minus 2x minus 3. Who remembers how to factor?
Oh, baby.
Anybody remember how to factor this?
I shouldn't have said algebra.
Okay.
Isn't it x plus or minus 3 plus 1?
Yes, absolutely. This would factor into 1 over. This would be the product of 2 linear binomials, right? And it would be x plus 1, and then it would be x minus 3. Okay, so you can factor these things, okay? Now that we have them factored, take a look at the denominator. Which 2 values of x are going to give us a 0?
1 and 3.
1 and 3. So how do we write the domain? We would say all real numbers x such that,
Wait, wouldn't it be negative 1 though? Negative 1 and 3, right?
is that what you guys said? Yeah. X is not allowed to be which 2 values? Negative 1 and positive 3. Absolutely. So this is how we would write the domain. Okay? So let's take a look at the graph and see what it would look like. Let me get rid of this thing. Let me get rid of this thing. So I said it was 1 over, what was it, x squared? Help me out, you guys.
1 over x squared minus 2x minus 3.
Minus 3. Good. Okay, so if I actually graph this thing, let's take a look at this. Hey, that's a strange looking graph, right? But all I asked you to do was find what? Yeah, so if I graph the line x equals 3, check it out. Is that where we said a domain value couldn't exist? And then what was the other one that we said? X can't be negative 1, right? So if I graph that vertical line, notice that I get the vertical asymptote at those 2 points. All right, once we got that part underneath our belt, we start talking about the operations that we can do with functions, okay? So if I was going to take two functions, so let's call them f of x, and I wanted to add that to g of x, all right? If I want to take two separate functions that I have, and I want to add them together, Jack, wake up, dude. Wake up. Stay with, buddy. And I want to add them together. Okay, the notation that we would use would be this. We would say f plus g of x. That's the notation that we would use, f plus g of x. Those two things mean the same thing on either side. Have you seen that notation before?
Yeah.
Yeah? Okay. So these are the basics right here. So what do you think this means? What does f minus g of x, what does that look like?
F of x minus g of x.
Yeah, it just literally means f of x minus g of x, okay? Not a big deal. All right, what about this one? What if I did f times g of x? What do you think that means?
F of x times g of
It
x.
just literally means multiply the two together, right? It just take f of x and multiply it with g of x. That's all you have to do. All right? So we've done the addition, we've done the subtraction, we've done the multiplication. What's the fourth one we're going to do? The division. So if I take f divided by g of x, what does that actually look like?
F of x over g of x.
F of x over g of x. But now, every time we have a fraction, what's always the thing that we have to be mindful of?
Make sure the bottom isn't equal to
Yes,
zero.
so we always say that the bottom, g of x, is not allowed to be 0. So you're going to be given two functions. One, f of x is 2x, and then the other one, g of x, says that it's 3x squared plus 1. And I'm curious, I'm wondering, what does f plus g of x look like? Well, what does this mean, you guys?
All the domain and the range of both of them get combined.
They all get combined, but what's the definition of f plus g of x? What is it? It's just f of x plus g of x, right? Okay. And how much is f of x worth?
2x.
It's worth 2x. And how much is g of x worth?
3x squared.
Nice job, Adrian. 3x squared plus 1. So just rewriting this in standard form, I'd get 3x squared plus 2x plus 1. Oh, that's a bad box. Okay. Go ahead right now, write out f minus g of x for me and point to it. Raise your hand and point to it when you're done. All right. So I'm going to define two functions for you. I'm going to define the blue function, f of x, equal to an x plus 3, square rooted. And the red function is equal to the square root of an x minus 2. All right? So I want to know what's the domain when I add those two functions together. What's the domain going to be when I add the two functions together? So let's do this thing first. Everybody help me out. I'll put f of x over here in a cloud and tell me the domain for this function for f of x. What would it be? Negative 3 is a number. I want the domain.
X is greater than or equal to 3.
All real numbers x such that x is greater than or equal to negative 3. Perfect, okay? Now over here in the red function, the g function, tell me the domain for this one. What would it be?
All real numbers such that x is greater than or equal to 2.
Greater than or equal to 2. Okay. So far, so good. We agree with this? Okay. Now, let's take a different approach to this, right? What would it look like on the number line here? What would this look like on the number line? So if I put a 0 here and I put negative 3 here, for my blue graph, for my blue function, would you guys agree that that would be the graph?
Yeah.
For x is greater than or equal to negative 3? You guys agree with that? Okay, for the red function then, let's see here, 2. So if I put a 2 here, and then if I go a little bit lower here, wouldn't it be this graph here?
Yep.
Yeah.
Okay. So I'm curious as to if I add these two things together, what is the domain of the sum of those two things? So what this literally means, take f of x, right, and add it to g of x. So what do you guys think? The answer is actually in the picture. I wonder if you can see it. Yeah, Millie, what do you think?
All real numbers x is like x is less than or greater than or equal to negative.
Greater than negative 3? What do you think?
Greater than or equal to negative 1.
Greater than or equal to negative 1? What do you think?
I think it's just the blue line, so greater than or equal to negative. Yeah.
Greater than or equal to negative 3? Okay. Well, no, that's not it. What do these two lines have in common? What do these two graphs have in common?
That they both go from 2 to infinity.
They go from here over. This is what they have in common, right? That's what they have in common? So that should be the domain, right? This, if I add these together, this will give me the square root of x plus 3 plus the square root of x minus 2. So the part that they have in common is the domain of the sum of those two things together. So let's take a look at the graph and see if we can actually pull that information from the graph. So, well, that's a big thick marker. Let's do this one. So if I graph the equation y equals the square root of, was it x plus 3, and then I add to that the square root of an x minus 2. Let's look at the picture. Okay? So look at this picture here, and you guys tell me, what would be the domain of just that picture that you see? It's from 2 on, right?
But
So
it's not equal to 2.
yeah, it is. Yeah, you can plug in a 2 into that, right? That'd be a 0, and that would be 5, right? Yeah, it does actually go there. It's just kind of hard to see. All right, I can zoom in on this thing, right? But yeah, it's on there. Okay, so at 2, I'm up there, right? I'm good to go. So I want you to be able to connect this picture with this picture here. You guys follow along with this? So do you see why it's the overlap of the two, right? It goes from 2 all the way on to infinity, and that's exactly what the overlap of the picture has right there.
So it would just be
Yes, the domain for this would be all real numbers x such that x is greater than or equal to 2. That's exactly what that picture said. So there you go. There's the U-try. I've defined 2 functions for you, and I want the domain of f plus g of x. Everybody get that?
Yes.
Okay, awesome, perfect. Okay, so function composition, box number 6. This is the highlight of the lesson right here, function composition. Function composition is when we take one function and we put it inside of another function.
functionception.
That's right, it's like inception with functions, okay? So the way that we see this, right, do you guys see how like the g of x is sort of inside of the f of x function here? Do you guys see that? Okay, so when you see something like this, this is how you would read this. This is read as f of g of x. It's like a crazy prepositional phrase, okay? So f of g of x. Now the way that we write it in mathematics is we write like this, parentheses, f open dot g
Yes, it's circle.
of x. So it's not fog of x, even though it looks like the word fog of x, okay?
So that's supposed to be open.
It's
dot.
at
Yeah,
circle.
it's an open dot.
Wait, do you call it circle?
Huh?
Is it called circle?
No, it's just called f of g of x.
Donkey
Okay.
side.
Okay. So now what if I gave you this, right? G of f of x.
Maybe
Hey,
I call it.
how would we write this one, you guys? G of f of x, okay? And they mean different things, right? Depending on which one is inside of which one. So this one is inside of f, but yet f is inside of g in this one. Okay, so it depends on which one. There are going to be different ideas here, okay? Awesome. So let's play with this. Let's use the computer to play with this. If I ask the computer for f of, that's not an f, huh? Let's do f of 3. Does that come out right? Oh,
-1.
whoa, it's already making fun of me here. Let's do f of 3. The computer gives me 6.
Yeah, because it's
What's it doing?
it's 3
Doing
times
2x because that's the f portion of it.
Oh. Oh. So then what would f of 1 be?
3, 2. I lied.
It would be 2, right? What about f of 10? What would that be?
20.
That's f of 10, right? Okay, so 20. So no big deal, right? Okay, what about g of 1? What would that be?
1. -1.
Negative 1?
Yes.
Negative 1. You guys are correct. Okay. What about g of 3?
9 times 2, 18 minus 3, 15.
So 15? You guys read that? Okay. Now, let's ask the computer another question here.
G of 3.
Okay. What is f of g of 1? Oh.
It's like Cyberman. Like doesn't solve it.
F of g of 1.
6 doesn't.
Who thinks they have an answer? Who thinks they have an answer? Emily, what do you think it is? 30. What do you think? -2. What do you think?
6.
6. I have 3 different answers here. Let's see what the calculator says. Calculator says -2. Who said -2? Okay, how does the calculator get a -2 out of this thing?
Never mind. I looked at it on one.
The wrong one. Yeah, Zach, how does the calculator get -2 out of this?
I looked at it.
Well, don't you plug in 1 for the x value of g, and then you multiply that by 2x?
Yes, you plug in 1 for a value of g, and then you take the output of that and you plug that into f, right?
Yeah.
Okay, so how do you do this then without a calculator? So let's go back to this.
Just kind of go for it.
You just kind of go for it. I asked you for f of g of 1. This is what I asked you to do, right? So this literally means f of g of 1, right? Yes, it does. That's exactly what it means. That's by definition, okay? So g of 1 is equal to what? How much is g of 1 worth?
-1.
Yeah, it's equal to 2 times 1 squared minus 3, which is just -1. So what do I do with that -1?
Plop it back.
And then I take f of -1. So I plop that straight into that. And that gives me -2
Wait, so
as
you
my
work
answer.
from inside out.
You work from inside out.
So it'd
Absolutely.
be incorrect if you did because f of x is just 2x, so if you did it that way and you did like 2 times and then you put in 2 for all the x value, yeah, that's like the opposite.
That's the opposite, exactly. So what about this one, okay, you guys? What would g of f of 1 be? Go ahead and figure that one out with your head. You should have got 5 for this answer. Does it make sense to you guys that these two answers would ever be the same?
No. Well, if the functions were the same
value.
But
If the if the functions were the same, would they even be the same then?
No.
What's up, dude? No, right? They're not necessarily always going to be the same. And we're going to learn in section 1.8 that if they are the same, then it means something special. But for now, we don't have to worry about it, okay? But everybody got 5, right? We're good with this?
Yeah.
All right, cool. All right. Okay, here's what we're doing. You're going to be given 2 functions where their domains are going to be restricted a little bit, right? And then they're going to ask you for this down here. They're going to say, okay, they're curious now, what would be the domain for the composite function f of g of x? That's what they're going to ask you to do. I'm writing it down here for a reason in the right-hand corner, all right? So here's the deal. Let's do this together. I'm going to put this in the cloud, and I'm going to ask you, give me the domain for f only. What would be the domain for f only? What value would give you a 0 in the denominator? Emily, what do you got?
The domain is all real numbers except for 1.
Except for 1. Very good. So I want all real numbers x such that x is not equal to the number 1. Is everyone in the room cool with the fact that that's the domain for the red function? Yeah? Okay, good. Give me the domain for the green function, the g function. Give me the domain.
X cannot equal 0.
Very good. Absolutely. So the domain for this one is going to be all real numbers x such that x cannot be the number 0. All right? So here's the question. I have 0 can't go into g and 1 can't go into f. So what's the domain going to be of the composite of the 2 functions here? Anybody think they know what it is? What's your guess? Go ahead, what's your guess?
all real numbers such that x cannot equal 0 or 1, like 0, 1.
You are half right. Okay, it's going to be all real numbers x such that x cannot be something, right? We just don't know what the something is, right? But let's ask ourselves this. What does f of g of x actually mean? What does it physically mean, f of g of x? Which one's inside of which one?
The g is inside the f.
Okay, very good. So I could write this out. I'll do it in pink. So f of g of x. Can you guys see that? It's kind of light, right? So f of g of x. Okay. So whatever we do, right? Whenever we do with this function, we put g first, right? And then whatever g becomes, we run that through f, and then that becomes our output. Is that okay so far? Yeah. All right. So what's the very first thing that we're not allowed to put into g? 0. We can't put a 0 into g. I think
Isn't it x cannot equal 1 or 0?
No. Close. Okay. 0. Does everyone see why it can't be the 0, first of all?
Yeah.
Okay. X cannot be 0.
Oh, 3 or 0.
It's 3.
3 or 0.
Yeah, 3 or 0.
Because then you have to plug it back in to find the new one.
Yeah. So the first part of this is pretty easy because we look at the function. Well, since g is inside of f and g is not allowed to be 0, right? So that goes into our composite function. Okay, now though, what happens with this composite function, right? We put a number into g does something to it. Then we take that output and plug it into f, and f does something to it, right? That's the process. So what is not allowed to go through f? Yeah, M.
3.
No.
Wait, 1.
Yeah.
But like
1 is not allowed to go through f. Does everyone agree with that statement?
Yeah.
So the question is this.
X can't equal.
Yes. How do we prevent g from producing the number 1?
By not giving it a 3.
By not giving it a 3. That's exactly right. So here's what we have to do. Okay? G of x is never allowed to produce the number 1. Now let's talk about these things. Where does this 1 come from? How do we know that's there?
From the g of x's own domain.
From f of x.
Oh, yeah.
Yeah, right? This cannot be 1, right? So we're preventing g from producing the value of a 1. What is g defined as? Look at that green cloud. What's it defined as? 3 over x. So now this tells me that 3 divided by x is never allowed to be the number 1. So how do you solve that little equation?
So 3.
There you go. So x is never allowed to be the number 3. Therefore, the composite function, the composite domain, this is the answer. I want to point something out. Notice that 1 is allowed in that domain. Why is 1 allowed in this domain? You can tell me why. Emily, why?
Because if you put 1 under 3, you just get 3. And so you can plug 3 into the equation.
Yeah, if you plug a 1 into g, 3 divided by 1, well, that's the number 3. And then I take the number 3, and I'm allowed to plug the number 3 into the f function, right? So therefore, 1 is allowed into the composite function of the whole thing. Kind of a trip. Okay? Oh, okay. Go ahead and try this on your own. Give me the domain of f of g of x, given the two functions defined as above. You can work with Adrian.
Okay.
No. You're doing great so far. So everyone, here we go. Help me out. What would be the domain of f of x? What would be the domain of the red one? All real numbers x, such that?
Such that x does not equal -2.
Nice job. Very good. Give me the domain for the blue function, g of x. What do you got for me?
X is all real numbers.
Mm-hmm.
Such that x.
Not equal to 0. Okay, now, which function is inside of which function in this particular case?
G is inside of that.
Absolutely, okay. So the domain of this thing, I'll do this in orange for you. So it's going to be this. All real numbers x such that x is not equal to, so right away, what can we not plug into the composite function?
0.
0, very good. Okay, now what do we want to prevent? Emily, what do we want to prevent?
You want to prevent the answer to g of x to be -2.
Yeah, g of x can never be the number -2. Why not?
Because if you plugged it into the f of x function, it would be over 0.
Okay, Adrian and Amelia, does that make sense to you?
Yep.
Okay, we cannot allow g to produce a -2, so we have to prevent that, right? So, where do I go from here? What's my next step? This is where a lot of people get stuck. Yeah.
You make 1 over x equal to -2.
Yeah. So set 1 over x, because that's what it's defined to be, right? 1 over x is never allowed to be the number -2. Now, how do you solve for that?
Okay, so technically you would multiply by x,
Uh-huh.
it would be -2x, and then equal 1, and then you divide by -2, so it's -1 over 2.
There you go. So x can never be -1/2. So your answer is a -1/2. So the composite domain is x cannot be 0 and -1/2. Notice what number is allowed in the composite domain. -2. -2 is allowed, right? Because if I plug -2 into g, I just get a -1/2. If I plug a -1/2 into f, I will get 4 over 1/2, and I'm good with that. Yes?
So you're
So you try, so the red function is 1 over 2x plus 1. The green function is 3 over x minus 5. Give me the domain for the composite